So let's look at example 3 from our sum and difference notes. We are asked to find the exact value of tangent of alpha minus beta given the fact that cosine of alpha is equal to 4 over 5 and that alpha is between 0 and pi over 2. And then also given the fact that cosine of beta is equal to 12 over 13 and beta is between 3 pi over 2 and 2 pi. Okay, so there's a lot going on and we kind of have to work through some information. We're gonna have to work a little bit harder than we did in examples 1 and 2 to actually fill out this equation we are asked to use. So I think it's helpful to go ahead and remind ourselves what is the corresponding equation here? What information are we going to need to find? So we were told at the beginning of our notes that tangent of alpha minus beta is the same thing as tangent alpha minus tangent beta, right? That subtraction stays the same in the numerator, divided by 1 plus tangent alpha tangent beta. So that subtraction becomes addition in the denominator. So it looks like in order to do this calculation, we're going to have to figure out what the tangent of alpha is and what the tangent of beta is. And all we're given is information about the cosine of each of those angles. So we're going to have to do a little bit of work here. So let's go ahead and focus on angle alpha. We know that since alpha is between 0 and pi over 2, that it's in quadrant 1. So I'm going to go ahead and sketch that out for myself. Quadrant 1, oops, we have angle alpha. And since we know that cosine of alpha is equal to 4 over 5, we know that cosine is the adjacent side over the hypotenuse. We can say that the base of this triangle has a length of 4 and the hypotenuse is 5. And we either recognize that as a Pythagorean triple or we click fill out Pythagorean theorem to figure out what is that vertical side. We see that that vertical side is going to be 25 minus 16, which is 9. And the square root of that gives us that our vertical side is 3. Okay, and this is important because now with this complete triangle, we can go ahead and identify that the tangent of alpha is the opposite, which is 3, over the adjacent side, which is 4. And this is going to be a value, the 3/4, that goes in to our equation everywhere we have tangent of alpha. Okay, so we're halfway there as far as figuring out the necessary information to do this calculation. The next part is that we have to sort out what is the tangent of beta. So we're told that beta is between 3 pi over 2 and 2 pi, which means that beta is in quadrant 4. So if we sketch that out for ourselves, we can draw a reference triangle down here in quadrant 4 with beta right here. And we're told that cosine of beta is equal to 12 over 13. That means the adjacent side to beta is 12 and the hypotenuse is 13. And again, either using Pythagorean theorem or recognizing this as a Pythagorean triple, we know that the opposite side is going to be 5. However, since we're in the 4th quadrant, that's going to actually be negative 5 because we're below the x-axis. So from here, we can identify that the tangent of beta is equal to the opposite side, which is negative 5 over the adjacent side, which is 12. And that is going to be our second value that gets plugged into this equation up here. Okay, so with a lot of work, we're at a place finally where we can do this calculation. Okay, the calculation, again, it tells us that the tangent of alpha minus beta is equal to the tangent of alpha minus the tangent of beta And that's all divided by 1 plus the tangent of alpha times the tangent of beta. Okay, and we know from our work above that value tangent of alpha as well as the value tangent of beta. So we're going to go ahead and plug those in. So instead of writing tangent of alpha, I get to write 3/4. Instead of writing tangent of beta, I get to write negative 5/12. Okay, and remember, these are getting subtracted, so we're gonna maybe wanna put that in parentheses so that we keep track of that subtraction of a negative correctly. And then that's divided by 1 plus, let's see, 3/4 times negative 5/12. Okay, and here now all we're doing is cleaning up a pretty complex looking fraction, but we can handle that. In the numerator, we're going to have to get common denominators. So I'll multiply 3 to numerator and denominator of 3/4. That will give me 9/12. If I do minus a negative, that will become plus 5/12 up in the numerator. In the denominator, since I have 1 plus the multiplication of two fractions, I'll just multiply straight across, and that will give me a, it looks like negative 15 over 48. Okay. So I'm going to rewrite that actually in the numerator as 9 since I have the common denominators. 9 plus 5 will give me 14/12. And then in the denominator, this 1, I can think of that as 48 over 48 and actually rewrite that 48 over 48 minus 15 over 48 as a 33 over 48. Okay, I'm gonna pop up here since we're running out of room. We know that division of fraction is just the same as multiplying by their reciprocal, right? So instead of saying 14/12 divided by 33/48, I'm going to take 14/12 and multiply it by 48/33. One thing that I noticed right away is that 12 actually divides into 48. So 12 goes into 48 4 times. So that just kind of, that simplification there of that fraction or those two fractions makes the multiplication a little bit more straightforward. So I can do 4 times 14, which is 56, divided by 33 times 1, which gives me 33. So all of this tells me that the tangent of alpha minus beta is equal to 56 over 33.